Good morning, everyone. I hope you are doing well. It's 9 a.m., right? Okay, so are you ready to start our today's tutorial? I know you are checking the Excel sheet, and maybe some of you may need to open the My Access, right? So whenever you are ready, please type a yes in the meeting chat, and then we'll start. Thank you. So we have a few students that don't have a group yet. So could you please go to the Excel sheet and type in whether you want to join group 111 or group 261. So we have 6 students and you could join the 2 groups. So 3 students in each of these groups. If you already have a number, so there's nothing to worry about. That's done. All right, so thanks, Catherine. I guess you guys are ready, okay? So we will start. Um, First, we will look back our tutorial last week about classware, and then we will move to section 2 and section 3 about the test. We don't touch ANOVA yet. So you see your timeline. We are in week 5, and we are doing the test. So next week, as far as I remember, there's no online tutorial. Not sure if Rahul reminds you about this last night, but yeah. So from what I remember, that means we will come back in week 7 for ANOVA and correlations. And also in week 7, you have another practicum, right? So I am going to have a meeting with Rahul to discuss about your progress, and I will tell him that you finished for today. You finished the t-test in the tutorial, and he will decide what is the testable content for your practicum. But I don't think that he will cover ANOVA, from what I understand, because some students told me that last night he only covered like 10 minutes for ANOVA or something. So I would suggest that he test up to their samples to test, something like that. And he will send an announcement to you, hopefully. So don't worry about that. All right. So this is what we have learned so far. The S here is the section in your tutorial document. So you, right now, you should be very familiar with variable chi-square and descriptive. And then last week we did the chi-square. And you know there is a magic formula for forming the hypothesis for chi-square, right? Which means in the null hypothesis, we say there's no association. And you have learned other techniques such as we vote into different variables. All right, so before we start the t-test, do you have any question about anything that we have covered so far?
I just had a question about like the null and the alternative hypothesis. So in the lectures, Rahul is like framing it as so you accept the alternative and you reject the alternative. But I know in in the tutorials, you're saying you reject the null and you accept the null, which I know is statistically right. But like in the lectures, he's saying you accept the alternative because like it's business and like marketing. So I'm just wondering, like in terms of like the test, like which one should we say?
In terms of meaning, there's no difference, right?
Yeah.
And thanks for your question. And also, Rahul clarifies that what he says is for business. Okay, so to make sure that you can use, you can make a right decision in both cases, academia and both business. I only show you the right way to do it. But just in case that in your practicum or in your final exam, you say like, I accept the alternative hypothesis, I will consider like you are doing it in the right way, as long as the final conclusion is okay, right? I know there's some, yeah, you can be a little bit confused about, should I say accept or reject, and should I make a conclusion on the no or the alternative? So I would like to make it easier for your life, and I will not be so strict about that. But in the tutorials, I want to make sure that you know the right things. And in the lecture, Rowan will tell you more about the business. That's it. So, thanks, Vanessa. And is there any other question? Good. So let's move to t-test. One more thing that about your group project. So this is the due date. That is Friday midnight at in week 10. And he says you will need to support a report, which means maybe a Word document or a PDF document, and one data set that you use to me. And this is my email address. And still you have no group yet, please go to the Excel link and choose a group number. Alright, so let's move to t-test. This is the definition of t-test from our lecture slide, right? So test the assumption, something. But I can guarantee you that t-test is a very powerful test, but most people don't really understand what it is. So for myself, I just really understand about t-test like 2-3 years after the first time that I know it. And so there's a research school about experimental design, and for that kind of method, the t-test and MANOVA are the two main analyzing techniques for experimental design. So it's very simple, but it's so powerful. And today I wish that I can make you really understand about the 3 different kinds of t-tests, and you will know when should I use this one, when should I use that one, and why should I use t-test but not chi-square, and vice versa. So this is the definition, and I'm sure you have seen this slide already because he spent like 2 lectures to talk about t-tests, right? So last week and this week. So before we start, I hope that you can do me a favor. So if you don't mind, could you please rate how much you understand about the 3 kinds of t-test? So we have a scale from 1 to 7. So 1 is that you don't really understand, and 7 is you understand very much, and number 4 means you have neutral opinion, neither understand nor not understand. The reason I ask this question is that I will base on your answers to see how should we deal with the t-test in our today's tutorial. So if you understand it very much, there's no need to go back to the theoretical part again, and let's just focus on running the test. But if you are not so sure about t-test, I will explain everything again in details and slowly. So when you are ready, please put a number in the meeting chat, and please be assured that I don't touch anyone. Okay? Thank you. Right. Thank you. So most of the answers are number 3, and a few students have number 5. So which means um, just under the neutral, or maybe 5 is slightly understand, something like that. And we don't have anyone with number 6 or number 7. So I guess I will need to make sure that you understand the differences between the 4 kinds of tests that we have learned so far, including chi-square and t-test. So by the end of our today's tutorial, I hope that you will feel very confident for your practicum, because you should have already um, obtained the goals for today. That is, you should know how to run any type of t-test, right? That's number 1. Number 2, how to form the hypothesis. Number 3, how to make a decision and then write down the interpretation and conclusion. And if you are able to do it, the practicum is not something that is difficult. Alright, so first of all, so before we start the exercise, I'd like to show you a big picture of everything first, so that you see the connection between everything. So this is the basic procedure for any kind of t-test, including the one sample t-test, which means the simple t-test, or the independent t-test, or the pair t-test. So number 1, that is to determine what kind of test should you run. And if that is a t-test, then what kind of t-test, right? Number 2, similar to chi-square, number 2 is forming the hypothesis. Number 3, we will run the test and you will get the output. And of course, we will need the p-values to make a decision in step 4 and step 5, right? However, unlike chi-square, so for chi-square in step 3, when you pick up the key output, you will need the chi-square value, right? And you will need to see whether there is any violation of the assumption or not. So this time we are working on continuous variable, which means you don't have the chi-square values and you don't need to check for the assumption. But the only thing that you need to pay more attention is the mean and the standard deviation of your variable. Okay, so because you mentioned about the accept, the alternative, so for today's tutorial, I will show you how to use that term. So step 1, what kind of test should you run? Now, before talking about this, I'd like to show you how to run the test first, so that you can see the differences in the screenshot in the windows between the 3 kinds of t-test. So which means if I open the CARS data set, alright, so either in the windows of data view or variable view, either. Let's go to menu analyze, right? So this is where you run the descriptive and chi-square. But this time you will go down until you see compare. And compare what compare means. Because t-test will require us to have at least one continuous variable. And for continuous variable, the most powerful indicator is the mean, right? The mean, and it will go together with standard deviation. So for the test, we are comparing the means. So let's go down to you see compare means, and then you see one sample t-test, or other people say, oh, it's simple t-test, so that's it. The second one is independent samples t-test, and the third one is paired samples t-test. And also here is where you can see one-way ANOVA. So one-way ANOVA is not something difficult. It's just the expansion for independent samples t-test. Okay, so I'll quickly run this so that you can see what is the procedure. Now if I run the one sample t-test, maybe for an exercise that we have in the tutorial document. So it says people usually rely upon us to make a decision about buying a car, issue 14. So issue 14 is this one. Then I just select the variable just like you usually do, right? So move it to the right. So that's a step number one. Number two, you can see that we have a test value down here, and you will need to type in the box what is the number that you want to test. For example, you can type in 1, or maybe 5, or 6, or 4, or 3. So you are the one who chooses the number based on the question that you are given. And in this question, they say people usually rely upon us to make a decision, something. And we know that in our data set, most of the continuous variables are measured from a scale with a scale from 1 to 7. So 1 is something like, let's say, strongly disagree, and then 7 is strongly agree, and number 4 is the neutral opinion, which means neither agree nor disagree. So in this test 1, what you are required to compare is number 4, which means the neutral opinion. We type in number 4. So that's all, only 2 steps. Number 1, specify the continuous variable. Number 2, what is the test value, right? So then click on OK. Right, and you will get an output for your one sample t-test. The name of the test is right here. The first table will tell you about the sample size, the mean, and standard deviation, and what is the variable that you are working on, right? So this is the label for that variable. The second table will tell you the name of the test value right here, and p-value. This one. And also sometimes you will see T and DF. So if you are asked to report T and DF, I will show you how to write a decent interpretation later. So basically, this is the output for one sample t-test. Now, someone might ask, if I put more than one continuous variable in the test variable box, then what happened? Now, if I put more like issue 8 or belong and successful, fun, anything. Of course, I will need to choose continuous variables. I cannot run with categorical variable, right? And then I specify a test value up to my choice. So 1, 2, 3, 4, 5, 6. And what the software is going to do is it will run multiple one sample t-tests at the same time. So the first one would be a comparison between issue 14 and number 4. Second, it will be a comparison between issue 8 and number 4, and so on. So that means in the output that you are going to get, there will be 1, 2, 3, 4, 5, 6 rows for 6 variables. Okay, so if I click on OK, now you get the result, right? So for the first table, you have 6 rows, and so on for the second table. Of course, you will get 6 p-values right here, or 6 variables. So that's how one sample t-test works. Alright, so let me run one more example for you. Like test 4 in our section 2, people usually rate the importance of security at a 5. So which means we are working on security and number 5. So I will go to menu analyze, compare means, one sample t-test. I will reset first and gain security. Where is it? Oh, this one. I move it to the right, and then my test value is number 5. So I will specify that it's number 5. Okay. Right. So still you have 2 tables, one statistics and one for the main result. And this is your p-value. Now, one more example. If your question asks whether do people care about mileage of the car, so from that question you can see that the variable that they are mentioning is mileage of the car, high gas mileage, right? So what number should we compare with? So again, this is the neutral opinion, so it should be number 4. So I will go to compare means and one sample t-test. So mileage of the car, where is it? Maybe this one. Alright, gas mile. So the test value would be number 4, right? If they don't care, which means they have neutral opinion, so number 4. Okay. And you get the result. So simple, right? Now I'm going to show you one more technique to work with one sample t-test. Right. So remember that I have just tested whether people care about mileage of the car. Now, if the question is, do females care about mileage of the car, then what is the difference? If you go back to your data set, you see that in the sex, we have 2 values, right? Female and male. And that is, we have 57 females and 88 males. So if the question is whether females care about mileage of the car, which means I need to run the one sample t-test with the 57 females only. So to do it, first of all, we need to specify that, oh, now I just want to work on the 57 females, but not the 155 people in my data set, correct? All right, so Isaac, your question is, how do you know what test value to choose? So if you look at the test 4 in section 2, they say people usually rate the importance of security at a 5. So that is very clear, right? So your test value is 5. And right here, if your question is just something like, females do not care about the mileage of the car. So which means in this case, your test value is number 4. Because in your data set, your variable was measured from 1 to 7. And 4 was the neutral opinion, which means neither agree nor disagree. So that's why I select number 4. Now this is also a good question. In other cases, when you do your own research and your neutral opinion is not number 4, but it's number 7. So to see whether people care about something, you should compare your variable with number 7, right? No longer number 4. So it depends. All right, so let's go back to the question. Do females care about the mileage of the car? So to do it before I run the one sample test, I will need to specify that I just want to test the 57 females right here, but not 155. And this leads you to a new technique, which is called select cases. Select cases will have you to choose only a subsample in your data set before you run any test. So to do it, I will go to menu data right here. And this is the first time that you use data menu, right? Last time I introduced you about recoding, but recoding is in the transform, right? Now this time you will go to data, and you will scroll down until you see at the bottom, you will see select cases. So this one, if I click on that, I will see that there are several options on my right hand side, and the default option is all cases, which means whatever test that you ask SPS to run, it will run for the whole data set. But right now I just want to run it for a subsample, which means the females only. So I will choose the second option, if condition is satisfied, and then I will click on if. What do we do? To select females only, which means that is variable sex, right? So I will select sex and move it to the right. And I know that female means sex is equal to 0, right? Because 0 is female and then 1 is male in our data set. So I will say, please select sex is equal to 0 for me. And then I click on continue and OK again. Now you go do the one sample to test. That is for the females only. I will go back to compare means, one sample to test, and then hide Dar's mileage, test with number 4, and there's nothing else that I need to do. Then I click on OK. Right? And you can see that how do you know this is for females? If you look at the sample size right here, you will see that N is 57 only, which means only females. Now again, if I run this for males, what do we do? Go back to data, select cases, and then sex is not 0, but sex is number 1. 1 stands for males. Continue. OK. And then I will run the one sample to test. It's there already, so I just click on OK. Right, so this time you can see that the sample size right here is 88. So that's how you can run the test for a subsample in your data set. Okay, so similarly, if you look at question 2 in section 2, power is an important attribute in the purchase of a car for men and women, which means there are one sample test right here. I should run one test for men and then another test for women with power. So to do it, I will go to analyze, because we are selecting males already. So I will go to analyze and compare means, one sample to test, and we will work on power. Where's power? Here. Okay. Let's say I want to compare it with number 4. So OK. Then I will get the result for males. And to select females, I will go back to data, select cases, if sex is 0. OK. And rerun the test. Okay. That result, right, for 56 females. Why 56 but not 57? Because in your data set, when you survey your respondent, sometimes they will skip some question. They didn't give you the answers. That's why sometimes you have some missing values in your data set. So that's it. All right. So I'm going to give you 5 minutes to explore one sample t-test, and you can run it for test 1, test 2, test 4 in section 2 of your tutorial document, and also for test 4 in section 3. So these are one sample t-test, and I will just run it for you. So now it's your turn, and if you have any questions, just let me know. And we will do the interpretation later. All right, so you have 5 minutes to play with the one sample t-test. All right. So, does anyone have any question, or do you need more time to run the one sample t-test? Look like all good, right? Okay, 3 minutes more. Sure. In the meantime, just would anyone mind if off? Okay. So it's not responding. Alright, so we have only 3 members for group 111. And of course, there are 2 students um, that they didn't specify whether they have a group or not, and they are not here. So I will email them later. But it could be that they form a group with students from other tutorials already. We are not sure. So group 111 could be at risk, right? Because Rahul doesn't accept 3 members. So would anyone from group 456 or 123 or 261 mind if you move to group 111? I just need one more student for group 111 to make it 4 members so that this group will be 6. So if anyone happy to do it, just please type the new group number and then you can adjust this one. So I will contact the student on row number 3 and number 19 later, and if they still available, I can add them to your groups later. But right now we really need one more student for group 111 so that it's safer for them, right? All right. Are you okay with the one sample t-test, or anyone need more time? Okay. All good? Cool. So we will move to the independent sample t-test. Now, let me show you how to apply the t-test um, in reality when you do a research or whether you do a industry research. I'm going to show you a very interesting uh, research project that they use the t-test to analyze their main result. So it should be here. All right. Okay. So let's look at the 2 copy boxes right here. Now this one is not a good example. So I guess this one. pictures. Right here, you can see two matrices, one on the left and one on the right. And if you read the price, it's actually the same price, right? So this is original price and this is their sale price. So this paper working on how to reframe the sale price so that the consumer will purchase the products more. And they believe that the original, the traditional way to frame the price is like to say, oh, this is now 37% lower. And they propose that there's a novel way to frame the price, which means to do it reversely. So they would say was 59% higher. And actually, these numbers are the same. But if they are right, which means the new way to frame the price will be more effective in stimulating the sales of the product, right? This is so much meaningful for the business because you actually don't pay anything. You just need to reframe how you show the customer the price, and your sales increase. Great, right? So they did an experiment in which they show half of the participants the traditional way to frame the sale price, which means 37%. And then for the rest of the participants, they show them the novel framing right here was 59%. And then for both groups, they asked for the purchase intention of these participants, like from a scale from 1 to 7. So what is your willingness to pay for the product? So which means 7 is very much and 1 is not at all or something like that. And then they compare the purchase intention of the two groups, right? So for the second group, if the purchase intention is higher than the first group, which means their new framing is working and is effective, right? So this is how they apply the t-test. So the t-test will have you to compare the mean of something between two independent groups. So in this case, they are comparing between the purchase intentions of group 1 and group 2. So that's how t-test works. And this is how they write up the result. You can see that they report right here. This one is the mean and standard deviation of the first group, right? This is the sample size. And this is the t-test result. The t value, the degree of freedom, the p value, and this is the sample size for the second group. And this is the mean and standard deviation. So I am going to show you how to run the independent sample t-test and how to get these outputs. Alright, so let me go to the tutorial document first. Alright, so we have one independent sample t-test on page, no page number. Okay, that is test 3 of section 2. So he says, men and women do not differ on their requirements of power from the car. So whenever we talk about independent sample t-test, you must be able to specify what are the two groups, right? So right here, the two groups are group of men and group of women. And what we want to test is the power of the car. So to do it, first of all, we need to select all cases. And then with the independent sample t-test, I will go to analyze, compare means, the same place with one sample t-test. So I will select independent. Why independent? That is because the group of men and group of women have no connection. Later, when you move to paired samples, you will see that there is a connection between the two groups. But right now, there's no connection. So these groups are unrelated. So I will choose independent. Reset. So we are working on power from the car, which means I will select power. What is it? Oh, it's here. Okay. I move it to the right, and then I will need to specify what are the two groups that I want to compare the power. So the two groups are men and women, which means sex. So I will choose sex and put it into the grouping variable. All right. So it's not done yet. Why? Because for independent sample t-test, we are only comparing two groups at the same time. While for the grouping variable, sometimes you have more than two levels. For example, if you choose age, you will see that you have 5 groups within the age, right? So we always have to specify what are the two groups that we want to compare in the independent. And to do it, we will click on Define Groups and specify that within the sex variable, I am comparing between group 1 and group 0. So I will put 1 here and 0 here. And if you don't like this way, you can put 0 here and 1 here. The p-value doesn't change. Alright, so I click on Continue. So again, to run the independent sample t-test, there are 3 steps. Number 1, specify the continuous variable. Number 2, choose the grouping variable. And then number 3, define the groups, which means which levels you want to test. Then it's done. Now you just click on OK. And then we get the result. So this is the output for the independent samples t-test right here, because I see the name of the test. And similar to the one sample t-test, it will have 2 tables. The first table will tell you about what were the variables that you used before. So here you have power and then sex. And for each level of sex, which means female and male, you have sample size, you have the mean, you have the standard deviation. Right here. Now let's move to the main result. Within this one, you can see that we have the p-value right here to tell 0.848 and 0.851. So there are 2 p-values, and I will tell you which one should we select later. And also you have the T and DF right here, degree of freedom. So this is independent sample t-test. And you can also see that the sample size of each group does not necessarily the same like the other group, right? So I have 56 females, but I have 88 males. That's not a problem. Okay, so that's independent. See whether we have any other example. All right, I'll run one more test with this kind of test. So test number 3 in section 3. The importance of high mileage does not differ between men and women, which means again the grouping variable is sex and the continuous variable is high gas mileage. So I will go to Analyze, Compare Means, Independent, and what I need to do is just sex is grouping variable already, so I just need to select high gas mileage. This one. Now, if you put more than one test variable right here in the box, that means you are running multiple independent samples t-test at the same time, and you are using the same grouping variable for this continuous variable. Right, so because in the 2 exercises we are working on sex only, so I can combine test 3 of section 2 and test 3 of section 3 together. So if I just run it like this, I will get the result for both exercises. Okay. Right. Now you can see that in the first table, you will see we have 2 groups for power and high gas mileage. And we have all of the sample size and mean and standard deviation. Similarly, in the second table, we will have 1, The upper part is for power right here, and the lower part is for high gas mileage right here. And of course, I can run the independent samples t-test for 50 continuous variables at the same time. Doesn't matter. All right. So I'm going to give you 5 minutes to run this test again by yourself, and let me know if you have any question. This one. Alright, are you all okay with the independent sample t-test? Then if everything is okay, I'm going to show you how to run the pair sample t-test, and then you will have a 5 minutes break. Oh. Okay, so I will take one exercise from our document. High gas mileage and speed are not given the same importance by respondents. So if you read this sentence, you will see that there are two continuous variables within this sentence. The first one is high gas mileage, and the second one is speed, right? There's no categorical variables, there's no groups, there's no test values. So in this case, we will use paired sample t-test. Now, this is the key point on when to use the independent and when to use the pair. So remember that when you run the analysis for the independent, you are analyzing two separate groups, right? But for the pair sample t-test, you are running the analysis for the same participants. So basically, there's no two groups, there's only one group. Why I say so? So pair sample t-test only happen when you ask the same participants to evaluate something twice. So the same people give you their evaluation twice for a sample. Maybe I will survey 100 students about the satisfaction level with the university, and I will do it in T1 2020, right? And then 6 months later, I want to see whether their satisfaction level changed or not changed. So I will ask the same 100 students that I asked before to evaluate their satisfaction level again. So which means every participant in my data set evaluated their satisfaction level twice. Now I'll give you another sample. I'm having a bottle, right? So this is my product, and I want to see how consumers perceive about my product. So I'll ask I will ask 1,000 people, please evaluate the price of my product. And then with that 1,000 people, I'll ask them again, please evaluate the quality of my product. Right? So which means the same 1,000 participants answer you twice. So in that case, their responses create the pairs. So that's why it's called the pair sample t-test. And this is a very, very, very important point in helping you to distinguish between the independent and the pair. So now this is one interesting tip about sample size. For the pair sample t-test, imagine that I ask 1,000 consumers to evaluate the price and the quality of my bottle, right? Which means there will be 1,000 scores on the price and then 1,000 scores on the quality. If there's no one skip the question, if everyone will give me the answers, I will have the same number, 1,000 for price and 1,000 scores for quality. Which means when you are using the pair sample t-test, you are comparing the mean of two things. The sample size of each should be the same because you are asking the same people. So in the previous example, like I asked 100 students about their satisfaction level before and after 6 months, my sample size should be 100 for before and 100 for after. Unless some student no longer want to give me their second evaluation. But in general, that should be the same. Okay. So to run the pair sample t-test, we will go to the same place. This one, pair samples t-test. And if you click on that, you will see that we only need to specify what are the two variables that we want to compare the mean with. And of course, like I said, these variables come from the same participants. So let's say I will compare, like in our exercise, height guards mileage. Height guards mileage, where is it? This one. And then that is variable 1, and for variable 2 is the speed. Of course, you can always swap the positions of speed and height guards mileage. Okay. And this is the result. This is the output from paired sample t-test. So unlike the previous two type t-tests, you have 3 tables. In this case, the first table is similar. That is the mean, standard deviation, and sample size for the 2 variables. And like I told you before, the sample size here is the same, right? It's always the same, unless some of your participants skip their answer. Okay, you have one more table about correlations, but right now you don't need to pay attention to this one. Just ignore it. Then for the main table, you also have the T, degree freedom, and significance, which means the P value. So that's how you run the pair sample t-test. And again, if I run it this way, like if I put more continuous variable right here, for example, issue 1 with issue 2, and then maybe issue 1, and issue 3, and maybe issue 8 with maybe current comfort. That means I have 4 pairs, and that means I am running the paired sample t-test 4 times. So in your result, you will get 4 paired sample t-test output simultaneously. See, okay, so this table will become bigger, and you have the statistic for each of the 4 pairs, and similarly for other tables. And of course, you will have 4 p values right here. So that's it. Now I'm going to give you more minutes to practice pair sample t-test by yourself, and then 5 more minutes for the break, and we will come back at 10:15. Okay? And if you need more time to run the test, just let me know, or we will come back at 10:15. Thank you. And just one more thing, if anyone volunteers to join group 111, please let me know in the meeting chat. Thank you. Vanessa, thanks for your question. So, after the break, we are going to discuss about the hypothesis. So, I will come back to your question later. Um, Group 111, are you still here? Group 111. There is a group with only 2 members in the tutorial of Wednesday 11 a.m. So would you mind if I integrate you guys into one group? That would be the safest option for you right now. Alright, so let's go back to our hypothesis development. So does anyone need more time to play with the test, running the test? Okay, so to sum up, you have finished running the test, and I have a summary slide for you on when should run the test. And this is an important slide. Now, to determine which test should you run, there are two ways. Number one, based on the requirements of the variable kinds. So you can see that for one sample, we are working on one continuous variable and one number. For the independent, you will need one continuous variable and one grouping variable. And that grouping variable is categorical, right? So it's quite different from one sample to test. And then for the pair samples to test, you will need 2 continuous variables. And well, for the case where you need 2 categorical variables. So the distinction between the 4 kinds of tests that you have covered up to now is so clear. Any question about this one? So if you understand that the requirements for each of the tests is very different, you won't be able to run the wrong test, right? That's way number one. Way number two, based on the purpose of the test. So t-test is comparing the mean, because t-test always involves at least one continuous variable, which means we are always comparing the mean of that variable with something. So in the case of one sample, you are comparing the mean of your continuous variable with a test value. While in the independent variable, independent t-test, you are comparing the mean of your continuous variable in 2 groups, right? And in the pair t-test, you are comparing the means of 2 continuous variables. So the purpose of the test is to compare the mean. And compare means it could be equal to or greater than or lower than. So that is comparison. Now for the case where we are not having the mean, because case where only work on categorical variables, so how can we have the mean? Which means that there's no comparison, right? And for case where we only test whether there is an association between 2 variables or not, that's all. There's no mean, there's no comparison. So if you understand all of the information on the slide, choosing the right test is super easy right now. Okay, any question about step 1, choosing the right test? All good? Okay, so now step 2 is writing the hypothesis, right? And for the t-test, you are able to write the hypothesis in 2 forms. Number 1, mathematical. Number 2, you can write in words, right? So I'm showing you how to write general hypothesis for t-test mathematically. So there are only three situations when you write the hypothesis for t-test, and please make sure that please understand that this is not applicable for chi-square. Right? So what you see here is mu. So mu is the mean for your population. So what is the mean of the population? Imagine that I want to survey the satisfaction level of students of UNSW, right? I am unable to survey 40,000 students or something. So that is the population. So if I can do it, if I can survey all of the students of UNSW, mu is the mean of the satisfaction rating. So mu is the mean of the population. But in reality, no one can do it, right? So what I can do is just I can survey a subgroup of my population, which means a sample. So I can only select maybe 5,000 students or 300 students or something. So I can only survey a sample within my population. And the mean, the M, is the mean of your sample. So M is not the mean of your population, but your sample. And mu is the mean of the population. So in summary, whenever you write the hypothesis for t-test, there are only three situations when you compare your mean with something. So for in your alternative hypothesis, which means the hypothesis that you want to test, you are saying that there's a difference between your variable with something, or the mean of your variable is lower than something, or the mean of your variable is higher than something. So only three situations, right? And of course, once you have the alternative, the null hypothesis is the opposite, which means here you have different. So the hypothesis is equal to. And if you have lower right here, so in your null hypothesis, it is higher than or equal to. And if you have greater right here, which means in the null hypothesis, it is lower than or equal to. Easy, right? So any hypothesis that you write in the t-test would be fall into one of the three groups that you see here. And what is something? Something here is when you run the one sample t-test. So something is your test value, right? So you are comparing the mean of your variable with that test value. And in the independent sample t-test, something here is the mean of the other group. This one would be the mean of the first group, and this one would be the mean of the second group. And if you are in a pair sample t-test, something here would be the mean of the second variables, right? Okay. So if you understand about this one, writing the hypothesis would be very easy. Right. Does this apply to chi-square? Of course not. In chi-square, we don't have the mean, and we are not comparing anything. So this only applies to any kind of t-test. Another question, do we have the equal sign in the alternative hypothesis, which means maybe equal to or higher than and equal to or lower than and equal to? The answer is no, you never have the equal sign in your alternative hypothesis. Why? Why? There is no equal sign. Let me take the first example to explain to you. The equal sign here will mean that the mean of your variable is equal to something, right? Which means there is no difference between the mean of this and something. And no difference would be something that researchers don't want to explore. We always want to explore something new, which means something different. So something different should be in our alternative. So that is this side. And that's why you will never, never, ever see the equal sign in your alternative hypothesis. We don't want to test something that is no difference. Of course, there are some exceptions, but not many. Most of the time, we always want to explore the relationship or the difference between something and something. So in general, mathematically, there are only 3 situations like this. So when you are doing a practicum or when you are doing an exam, and if you are unsure whether you can write the correct hypothesis in Word or not, you can write this one. As long as it's correct, I don't see any problem with this. Okay, any question? In the next slide, I am going to show you how to transform this mathematical hypothesis into words. Right? And because we have 3 situations right here, so that's a lot. I will only take the first situation to make some example for you. Okay, so this one and this one. Right, so let's move to some hypothesis in words. And I'm going to show you a big picture of all the hypotheses for the 4 tests that you have learned so far. So this is for chi-square, right? There's no association between 2 category variables. For one sample t-test, for example, in the node 1, your mean is equal to testing value, which means, let me tell you one example. People rate security at 5. So mu is equal to 5. And right here it will be people don't rate security at 5. Now another example for the independent. So in your null hypothesis, it would be the 2 groups don't differ in something, maybe in their rating of security or whatever. So don't differ, or there's no difference. In the alternative, it would be the 2 groups are actually different, right? In something. So your magic formula would be whenever you talk about a difference or whenever you talk about an association in chi-square, that should be in your alternative hypothesis. Okay. Now the last one for the paired t-test. Similarly, in your node 1, that would be there is no difference in the way customer rates the first variable and then the second variable. And of course, in your alternative, it would be there's a difference between the 2 variables. Any question about hypothesis? Of course, if sometimes you have the hypothesis about greater or lower, you will need to adjust this slide. Like I said before, I only take this case to make example for you. Alright, so this is a common mistake. And I have observed lots of students or sometimes even based on how they form the hypothesis. So this is a big mistake. Some people believe that in the null hypothesis, or maybe they think in the alternative, there will be always the word not. So they always rely on this to form the hypothesis. This is wrong, totally wrong. Why? I'm giving you one example, like Pythagoras minus and speed are not given the same importance by respondents. And if I rewrite this sentence, it would be something like, there is a difference in the way customers rate Pythagoras minus and speed. So the meaning is the same. There's no problem in using the second way in your hypothesis, right? But you can see that in the second sentence, I don't have the word not. So whether you have not in your sentence or not, it's not a reliable criteria for you to determine your hypothesis. So don't rely on the word not. It's not true, it's not correct. The principle that I'm telling you is that whenever you talk about the difference, it should be in your alternative hypothesis. Question. Okay, so we move on. Now we have finished step 1, determine the test, and step 2, forming hypothesis. Let's move to step 3, decision rule. And this one is applicable for either chi-square or any type of t-test or correlation and regression in ANOVA. So if the p-value is small enough, which means it's smaller than 5%, you can say you reject the null hypothesis, H0. Of course, in business, they can say the other way around, like they can say, oh, I accept the alternative hypothesis. So in business, there's nothing wrong with that, because what the managers care about is your conclusion rather than what is the hypothesis. But in academia, to make sure that you are writing the right thing, you can make it this way. It will never be wrong. So if your p-value is too high, which means higher than 5%, you cannot reject the null hypothesis. Okay. And the p-value here means the possibility that you are making a mistake with your conclusion. So that's why the smaller, the better. Okay. Question. Cool. So that is step 3, right? Now, let's go back to all of the tests that I ran before for you, and I give you the time to run it. So right now, let's do a quick check on this exercise. So if we look at test 1, people usually rely upon S to make a decision about buying a car, which means issue 14. So we have one continuous, which means you are working on one sample t-test, and in this case, test value is number 4. The second one, power is an important attribute in the purchase of a car for men, full stop. Which means this is one sample t-test, but before that, you need to select the main only in the select cases. And then you run it a second time for women. So this is the tricky part. Test 3, men and women, which means 2 groups, do not differ on power or whatsoever. So you have 2 groups and one continuous variable, which means this is independent sample t-test. Test 4, people rate something at 5, which means that something security is your continuous, 5 is test value, right? Test 1, high gas mileage and speed are not given the same importance by respondents. And test 2, high gas mileage and speed are given the same blah blah blah. So we have 2 continuous variables right here, which means this is pair sampled t-test. And whatever test that you run for each of the 2 tests right here, test 1 and test 2, should be the same. The way that you run the test and your result, your numerical result, are exactly the same. So the problem is how you form the hypothesis. Okay, so for test 2, they say this one and this one are given the same importance, which means there is no difference about the importance of high gas mileage and speed, right? And you know that there is no difference should be put in the alternative hypothesis. Correct? All right. So for test 1, high gas mileage and speed are not given the same importance by respondents. If I were you, I see no problem when, if I test in the alternative hypothesis that the mu